Welcome back, students. Now our next step will be to calculate the flare distance. If we draw the diagram again, it is something like this. This is the V touchdown. Here's the flare. Flare means the airplane is coming like this. Okay? Let's see. This is the airstrip, and the airplane is coming like this. So near the airstrip, it will flare up, so that it touches the landing gear. So that it touches the rear landing gear first, and then nose landing gear. So it has to flare up, and this operation takes 3 seconds, maximum 3 seconds, and it happens at a touchdown speed. So this S flare FR will be 3 into V touchdown. V touchdown is what? V touchdown, you know, is 1.15 V stall. Okay? So S FR is also calculated. What is remaining now? Right? Now from here, I will be applying brake. What sort of brake is there? Anywhere they are resting on wheels, so normal wheel brake has to be there with high grade cylinder and pneumatic hydraulic systems. So that is a normal brake you have. Then also there are provisions. You can reverse the thrust of the engine. Okay? That is called thrust reversal. You can have option of putting parachute, inflate a parachute, which is done generally you'll find in fighter airplanes. If the land roll is or landing distance or the airstrip is not large enough to reduce it, they will be putting some parachute also. So these are the basic items which are used. Also you will see in many airplanes, especially gliders, you will see there are, if you see the glider wing, or earlier plane also, if this is the center line, there are surfaces called spoilers. So as I land, the spoilers will become like this. So they will also give lot of drag. Not only it will give drag, it will also spoil the lift over the wing when it's on the ground. Is it clear? So that will also help in reducing this distance. All this thing we are doing to reduce this distance SB. This is the understanding. Now let us see how can I calculate SB. That is our next exercise. So SB is termed as braking distance. So it has come like this, flared like this, and from here, which is V touchdown, to V equal to 0, I have to find out what is this distance SB. Go back to class 6th or 7th. How would I have solved this problem? Immediately I will see final velocity is 0, initial velocity is V touchdown, so I will write U equal to V touchdown, final velocity V is 0. I will assume average acceleration A, which can represent as if A is constant. Then what should I do? Then I will write final velocity is 0, so 0 square minus U means V touchdown square equal to 2A SB. So SB is minus V touchdown square by 2A, which is average. I don't require any BTech, MTech or PhD to write this equation. My knowledge at 7th, 6th, 7th, 8th was good enough. Okay? And we will be doing this extension of this thing in defining A average. You could see there is a minus sign. So don't think SB has become negative. This minus sign is here because A average is not an acceleration now, it is a deceleration because there will be reduction in speed. Okay? So that is negative, so negative and negative get cancelled, it gives a positive number. So what is our aim now? Our aim is to find out what is that A average. So let us now, as we did for takeoff case, we try to draw the free body diagram. aircraft is on the ground, so and it is V equal to V touchdown, it is coming down to V equal to 0. We want to find the A average, deceleration average. We know that this is the thrust direction T, this is the drag, lift, weight, and there is a friction FF, and of course we write R as the reaction from the earth to the airplane. Now once I write the equation, I get T minus D minus FF is equal to MAW by G into A. But as I understand now that drag is proportional to speed square, so ideally speaking A will change, A will not remain constant. Also I see that FF I can write as mu into R, and R I can find out R plus L is equal to W. So R is nothing but W minus L. So this equation becomes T minus D minus mu R, the coefficient of friction for rolling, into R, that is W minus L, equal to W by G into A. Now can you tell me how can I apply my common sense here to further simplify this? Remember, this is the equation. Now we have landed and we want to reduce the braking distance. So what should I do? Should I put the thrust here? Now no requirement of thrust. In fact, if possible, I will put a reverse thrust by the jet engine, the mass flow being changed in the other direction, or by changing the pitch of the propeller, right? Okay. So for first case, I am putting thrust equal to 0, which is obvious. Once I have landed, why should I keep thrust? So then I have equation like minus D minus mu R W minus L equal to W by G into A. Please understand here another subtle point. Once we want to model this drag through CD, I will write mechanically CD equal to CD naught plus phi k CL square because of ground effect plus delta CD flap plus delta CD landing gear and plus miscellaneous. As I was telling you, I can put a parachute, so that will also have a drag. But concentrate here. As I have landed on the ground, I want this component should be 0. Why should I need a lift? Okay? So naturally, that component goes. I ensure that there are no lift on the aircraft. So then the CD gets modified like this, right? So we are not really bothered about ground effect while going for a braking. This you must understand. Now after this, what do? We have to find A average. In fact, I need not complete this. You yourself will be able to do this in one shot. Well, expression for A will be G by W. I put a minus sign here. D plus mu R W minus L. Okay? And as we have done for our takeoff case, to calculate A average, the deceleration average, which will represent the overall effect to compensate for the complexities of deceleration being varying in nature. If I calculate A at same as 0.7 times V touch down, please understand, right? V touch down. If I calculate this drag, lift, I am least bothered, lift almost, it will be going to 0 because I don't require a lift. So this will give me an expression for A average. Okay. Now, since I know that V square minus U square, remember this equation earlier we wrote, so S will be equal to minus V touchdown square by 2a. So I will be substituting the value of a here. Okay? And I will substitute V touchdown as 1.15 V stall, which is nothing but 1.15 into V stall is 2W by S by rho CL max. You know, this is with flaps down. Please understand, when I am calculating V touchdown, the 1.15 times V stall by 2W by S rho CL max, that doesn't mean in the aircraft on the ground having a CL max configuration. This is for calculation we have calculated. To understand that, that is the speed with which we will be actually initial speed for the airplane. That's all. Well, it starts touching the ground. Okay, and then the speed goes on decreasing. Okay. Now, if I substitute all this thing into this equation, what I get? I leave it to you to just find out the final expression, which is as simple as just substituting this here and a from here. So you will get an expression like SB is 1.15 square W square by G rho S CL max D plus mu R W minus L at 0.7 V touchdown. If you see many books where they take V touchdown as 1.3 times V stall. I have seen, even many books I have seen, V touchdown they have taken as 1.3 times V stall, but we have taken V at 15, 1.3 times V stall. Note this change. So if you read some book, you may find that this value is around 1.69. That is, they have taken V touchdown as 1.3 V stall. But I have taken V touchdown as 1.15 V stall. Okay? So that should be clear in your mind. Don't get nervous about it. So let us understand. Those are details. Okay? Understand the physics behind it. What does this mean? It means I can reduce SB if I have drag is very, very high. Okay? How can I increase the drag? That is the question. What is done is the flaps will be now put to 40 degrees, which will not produce lift, but it will actually give drag. If it has the spoilers will simply stand up like this. That will give drag. Also, you will find there are airplanes, all sophisticated airplanes in fact, they have got something called thrust reversal mechanism. Okay? What it does? As I have touched down the ground, earlier thrust was like this, now the thrust will be opposite direction. So that will also reduce the braking distance. How that could be done? You know, it's a jet. If it is a jet engine, then whatever mass flow was being thrown out in one direction to get a thrust during takeoff, now through mechanism, same mass flow, you throw it in the opposite direction. Right? The thrust direction will change. Also for a propeller-driven engine, the pitch of the propeller, you can now reverse. So that earlier thrust was coming like this, now the thrust will be towards the airplane, and it will help in reducing the braking distance. Also I can increase drag by adding parachute, okay? Which I was telling, you will find most of our fighter airplane, they will be using parachute. The moment they land, after a certain distance, the parachute will be deployed, which will give enough drag, and that will again increase this value. So the SB braking distance will reduce. So you understand, so far we were all very annoyed with drag. Why drag is there? But now you understand how important is drag. Okay? So please understand that's why an intelligent person knows how to convert an advantage to a more advantageous situation or a disadvantage to an advantageous situation. And that is the role of a designer if he is really, in true sense, a good designer. And to get you that feel, to get you inspired to be a good designer, I am stressing all this point again and again. Okay? You can also see, now you are expert, you can also see that rho, if rho goes down, SB goes up. That means if you are touching down at a high altitude airport where the density of air is less than density of air at sea level, so that airport, when you are landing, be careful, you will be requiring larger braking distance. Okay? So by now you have learned how to approximately calculate SA, the flare distance SFR, and braking distance SB, and total landing distance for a single engine landing distance will be SA plus SFR plus SB. Okay? But it goes without saying, when you are designing an airport or airstrip, you will keep a lot of margin. How much margin to be kept, we will be discussing in one of our sessions. But this is clear now. You know how to calculate approximately the landing distance for a single engine airplane, maintaining the regulation or guidelines. Thank you very much.